so I'm sorry if that's kind of confusing. Now we'll do one together and we will see how it works. Okay, so the question is, determine whether the statements P conjunction the negation of Q, disjunction, negation of P, conjunction Q, and, whoops, I forgot the letter in here, and P exclusive disjunction with Q are equivalent. All right, let's find out. Let me get my blue marker, actually. Okay, so we always start our truth tables with the P and Q columns. So we'll start with P, Q, and here we have true, 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 false, false, true, false, false. And then we have not Q and not P, so let's do those columns next. Let's do not P, and let's do not Q. So that's pretty straightforward. So it would be the opposite of the P for the not P. So we have false, false, true, true, and then here we have false, true, false, true. And then we want to do, man, it's a long one. Okay, now we want to do P and not Q. Okay, so we're going to look at this column P and this column not Q, and if they're both true, then it's true. So we have a true and a false, so that's a false. We have a true and a true, so that's a true. We have a false and a false, so that's a false. We have a false and a true, so that's a false. All right, and then we have not P and Q. So that's this column and this column. So we have true and false. We have false. We have false and false, so we have false, then we have true and true, so we have true, then we have false and true, so we have false. And now, we'll bring it all together. So we have P and not Q, or not P and Q. So we'll look at these two, and it's a disjunction, so that means it's an or. So if either of these are true, then this one's true. So we have false, false, which is false. We have true, false, which is true. We have false, true, which is true. And then we have false, false. Okay, so that's that. Now we're going to do the other section, which is the P disjunction Q. So I'll do it here. So we have P, Q, and then we'll just do P exclusive disjunction Q. True, 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 false, false, true, false, false. So exclusive disjunction, they can't both be true and they can't both be false. It's the one that it looks like this. Okay, that's exclusive disjunction. So it has to be in P or Q. It can't be in both. It can't be in either. All right, so we have true, true, so that's a false. This would be a true, this would be a true, and this would be a false. So now we're going to look at both of them together. And we have false, true, true, false. And here we have false, true, true, false. So that means that, let's see. So that means we can make another one that pulls it all together. So let me just do that here. I'll do it in another color so that it's not confusing. So we have a new truth table that's P, Q, and then it'll be, gosh, it's going to be kind of long. All right, then we have P exclusive disjunction Q. Then we have, I'll call this star, then we have the star column, then we have the okay, so basically what I'm trying to look at here is we'll do our regular P's and Q's, true, 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 false, false, true, false, false, and then for our P exclusive disjunction Q, we got false, true, true, false. And then for this long one, which I'm labeling star, we got, again, false, true, true, false. And then We look at it all together, and that's looking at the biconditional equivalency. So we say these are both the same, so that's true, that's true, that's true, that's true. So it's a tautology, so the two statements are equivalent or biconditionally equivalent because their final columns are a tautology when looked at together. So it's kind of like really long to do the whole process, as you can see by this awesome truth table, but none of it is ever like really that demanding. It just is tedious. So you don't have to be like a brain surgeon to do this. You just have to have patience and go slow and make sure you don't make mistakes. Okay, cool. We can do some in class together.